Maples.
I'm Miguel, Chamu.
Arreola.
And we chose to do the project number 2, the audio processing project. And here's our code right here. And so if I run this code right here, we already have some stuff loaded up here, but as you can see, we have slots over here where we can load different WAV files, and we have here a frequency versus time graph, chopping, special effects over here. We have a basic tone generator, a little keyboard, and then we have a loop sequencer over here. We can loop songs together. So basically, if I want to load a song up or a WAV file up, I just click on load. And my computer is being really slow right now, so just bear with me, please. So I can load up right here, Pac-Man WAV file. Open that. It's taking a minute here, so I can play that. Loud. So yeah, as you can see, there's the frequency versus time. So if we go back to our code here, come on, it's being really slow. So we go right here to line 488. This is how we files right here, and there's a separate code for each load button, and then sets the frequency and amplitude and so on and so forth. And the graph, the frequency versus time graph, is worked out right here. This is a play button right here, and at the same time it'll create a graph generating the frequency and the amplitude of the files. And yeah, that's about it. So I'm gonna turn it over to Eric right now.
Okay, so for the special effects, there's 6 of them. And sample reversal, the first one is just reversing the audio. So say this is the audio. So it's that, and if I were to reverse that audio, something like that. And the frequency versus time graph just flips because it was reversed. And to see that in the code, that is, so that is this function. So what this function does is right here it gets the data, gets the amplitude, the audio itself can be flipped, and then it assigns that to that's the new audio. That's basically how that works. For the next effect delay, it just adds a delay to the song. Let me flip this real quick. Oh, let me flip that. So, that was. So there's a delay. This adds a delay to the sound effect. So what that would sound like is. Load it in a new one. Don't reverse. Okay, so we add the delay to it. Should be added by now. Okay, see now the frequency versus time graph changes to show how we change the actual sound effect itself, which is just adding a huge delay before the actual sound plays. And how that looks in the actual code itself is like this. Oh. So for this one, so we're assigning the data, and then we're getting the amplitude of it, and we're making an empty matrix. It's about the same size as the first two. And then we're having a temporary to hold in that matrix that we fill with the amplitude. And from that, we just so the blank is just the delay before the audio actually changes itself, and then we stitch them together so that there's a huge delay before it. straight out, so for tripping out quieter, so you can hear the end of the audio, and that function oh, I got so that's this one. So for this one, you're just grabbing the amplitude, stretching out the audio gets stretched out. For the next special effect, which is speed up. I mean, we're just speeding up the audio by 2, so it just gets faster. It sounds like this. Let's get that one went a lot faster. Sounded a lot different than before. That one is 23. So in this function, we just grab the frequency from the data and we multiply it by 2 so that the actual audio itself gets stretched out. We send that to the old data so that it comes in new audio, and that's how it gets stretched out by 2.
Okay, so I'm going to talk about the chopping first. So let's yeah, this will pretty much chop any part of the .wave file that you want to only be played. So pretty much.
And Barry Bonds at Packville Park hit it to the deepest part of the ballpark.
We have the graph right here, so let's say we want this first. We want it to start at 4 and let's say end at 10. And then if we apply that,
Deepest part of the ballpark. The 421-foot marker in right center field. And
dot wave audio, it started at 4 and it ended at 10. So the code for that is right here where we see that. So this is pretty much the function where we select where we code where we want it to start and end, and we can see it here where we extract the song data with where the frequency starts and the frequency finishes. And that's pretty much how we are able to chop the wave file. And then the loop right here, this is our sequencer where we can loop several files at once. We'll load another file. So here we're gonna start the loop, and we're gonna see it's gonna loop all the way around.
And Barry Bonds at Packville Park hit it to the deepest part of the ballpark. The 421-foot marker in right center field. And that's where he went to become the greatest single-season home run hitter in the history of this game.
Yeah. So it'll keep looping until we stop the loop. So how this one works, we use the while loop to wave files, and then the code for that is right here. We started the while loop. As long as the loop in the structure of the song data is equal to 1, it'll play the song data in each slot. So it'll run through each wave file from start to finish, and once one song dot wave file is executed, it'll move on to the next wave file until they all finish. And then as long as the song data loop is looping all these files, and then to end the loop, we have the code right here where if the song data loop is equal to 0, then it'll stop playing all the .wav files immediately. And yeah, that's that function. And then we have this the basic tone generator, which pretty much generates different frequencies. We have and then the code for that. Right. So the code for this is right here, where we see we have different namespace functions to generate different frequencies, and yeah, that's pretty much how we were able to generate different frequencies by changing the frequency of sine for each. And that's basically it for the tone generator. This is our entire project. And
Thank you.
thank you for watching.